Hi everyone. In this session, I'm going to present you with recent updates of our work on the universal soil classification system. So this work is done in collaboration with co-authors from different institutes across the world. And we call this new system developed as a comprehensive soil classification system 2.0. So the background of this study comes from the soil classification. So we all know that soil classification is important to understand the variation of the soil across the landscape. However, due to the different criteria used in soil classification, it is so difficult to make any cross-reference for soils identified using different countries' classification schemes. Recent efforts have been used to build classifications representing world soil, such as the World Reference Space, but also the USDA soil taxonomy. However, it's still difficult for people to adopt these new systems in countries where there is extensive prior knowledge on soil classification with the existing or old systems. So recent research done by our group have attempted to build a dynamic comprehensive soil classification system, CSCS, by sequentially adding existing soil data from the existing global or regional systems. So by doing this, we can create a database that is made of soil taxa or centroid of the soils at different levels from different countries' systems. So those centroid of the soils represent the measured soil properties, including the morphological, such as soil color, the physical, such as the particle size, and the chemical, like pH or exchangeable cations, measured at different depths of the soils, ranging from 0 to 1.5 meters. So the recent work has been demonstrated in Figure 1. As you can see here, the existing soil classification system, CSCS 2.0, has 398 centroids represent the soils from different existing systems, including the soil taxonomy, the WRB, Australian soil classification system, New Zealand soil classification system, the French soil classification system, Russian soil classification, and Brazil soil classification system, and Korea soil classification. So different systems are identified in this graph in the principal component space, use different colors. So we can see that different country or national systems capture different space in the principal components. And by using this principal component plot, we can identify which soils are more close to each other and which soils are more different from each other, not only within the system, but also across the system. And we also create a function for others to allocate any unknown soil profiles with the measured soil physical, chemical, or morphological properties and into this existing system. So a sample function in R looks like this. So the users only need to prepare a spreadsheet in the Excel file of the measured soil data for certain profiles at different depths and for different properties. After that, you just download this function from the website from here, then run this function in R. So then the outcome of this function will give you this soil classes for the unknown soil profile. It will tell you what are the closest taxa in the existing system to this new or unknown soil profiles. Based on this distance, we can allocate or assign the unknown soil profiles to the existing names in this CSCS 2.0. So in conclusion, this new classification system categorizes soil taxa in the principal component space and defined by the central values. And also it allows for identify unknown soils in a quantitative way and use the existing soil data. All the input data required here is to measure the soil properties at different depths. And the users can allocate this soil to the existing soil taxas, use the existing names of the system, but also provides a new nomenclature of this system, which is developed in a systematic way by grouping all the classes in the existing CSCS systems. So in the future, we hope to continue adding taxes from other regions of the world. So this principal component space can occupy the remote empty space can be occupied by this new data. And if you have any questions, feel free to send me an email. But also, you can look for the more information on this GitHub website.